Welcome to yet another session of electronics and embedded systems. Here we are discussing NB-IoT, Nearabot IoT. This is the fifth video in the series. Already I have released 4 videos. Kindly watch them before watching this video because we will not understand much if you watch this video alone. Integration into NRF Connect SDK. On top of this, we have the modem library integration layer, which integrates the modem library into NRF Connect SDK. This layer consists of the library wrapper and functionalities like socket offloading, memory partitioning of the shared memory region, handling modem tracing and diagnostics. Interacting with the modem. In this session, we will take a closer look at how we communicate with the modem core on the NRF 9160 SIP. We will start by introducing the NRF 9160 communication stack and move our way through the layers. On the modem side, you will learn about the transport layer protocols, TCP bar UDP, and the accompanying TLS, DTLS, and the advantages and disadvantages of each. Then we look at how the modem side and the application processor side communicate through the modem library and socket interface in Zephyr. Network programming. Any firmware running on the application core of the NRF 9160 SAP that wants to utilize the modem core must interface with it. And before we cover how to interface with the modem, it is useful to have a basic understanding of network programming using internet sockets, or better explained, socket programming. Socket. A socket is a software structure that serves as an endpoint for sending and receiving data across a network. So the client requests a connection to the server, and then the server accepts the given connection request and then establishes a connection. A common scenario. A server runs on a computer and has a socket that is bound to a specific port number. The server listens to the socket, waiting for a client to make a connection request. On the client side, it knows the host name of the computer and the aforementioned port number, and it will try to make a connection request by binding to a local port number that it will use during the connection. If the server accepts the connection, it will get a new socket bound to the same local port with its remote endpoint set to the address and port of the client. Then it will keep listening to the original socket for the new connection request while handling the connection. A socket is also created on the client side, and the client and the server can communicate or writing to or reading from the respective sockets. Transport layer. The NRF 9160 gives you the freedom to choose between a number of data delivery options. You can choose to use IP packets or non-IP packets. In addition, when choosing IP packets, you can further specify the complexity level by choosing either TCP or UDP. So this is the overall structure of the transport layer or data communication layer. Now we are going to see TCP UDP. TCP and UDP, the two communication protocols that make up the transport layer in the NRF 9160 communication stack, is the Transmission Control Protocol TCP and the User Datagram Protocol UDP. TCP is a connection-oriented protocol that uses a three-way handshake to establish a connection between server and client before beginning to send data. It provides reliable, ordered, and an error-checked delivery of a stream of bytes. UDP is a connectionless protocol that does not require an established connection, but rather transmits packets called datagrams directly to the receiver, as opposed to TCP. This does not provide ordered or error-checked delivery. The two protocols have a number of advantages and disadvantages that become relevant when choosing which one to use in your application. The following table summarizes the main advantages and disadvantages of both TCP and UDP. Advantages of TCP. It has data retransmission capability, congestion control, in-order delivery, and error detection. Disadvantages of TCP. Slow handshake, larger overhead, repetition if data is not received. UDP. Advantages. Though handshake is needed, better suited for low power devices. Disadvantages. Not guaranteed delivery. Can be enforced by the application layer. Not all major cloud vendors support UDP yet. Being a simpler protocol, UDP has fewer overhead bits and no handshake. This creates a number of advantages such as the lower power consumption associated with the absence of handshakes. However, this can lead to higher data loss and packets can arrive out of order, but it can be solved by the application protocol. On the other hand, TCP is a more complex protocol. It offers packets awareness, which means the transceivers are aware of the order of packets being sent. So any lost packet can be detected and retransmitted, and any disruption in the packet order can be corrected. Of course, this results in increased overhead and power consumption. Transport layer security. To secure the transport layer, the NRF 9160 modem further offers transport layer security protocols that provide confidentiality, integrity, and authenticity to communication. Confidentiality. The communication cannot be read by third parties along the network path. Integrity. The communication cannot be altered by third parties along the network path. Authenticity. Verifies the identity of the both sides of the communication on top of the transport layer in the NRF 9160 communication stack. We find the layer for transport layer security protocols TLS and DTLS. So now we are talking about TLS and DTLS in the communication stack. TLS and DTLS, the two protocols that make up the layer or the transport layer security, and datagram transport layer security, which provides security for TCP and UDP respectively. TLS is an encryption protocol designed to provide security over a TCP connection. When establishing a connection between the server and client, the client requests a TLS connection. One of the main ways of achieving this is to use a different port number for TLS connection, as we will see in next videos. DTLS is an implementation of TLS that is specifically designed to be used over datagram based communication and is intended to provide similar security guarantees. To do this, DTLS requires a handshake prior to transmitting messages, where each handshake packet has a specific sequence number to solve the fact that UDP does not provide ordered delivery. For the application, the difference between using TLS and DTLS is insignificant, as both protocols provide the same type of security. NRF modem library. This section will touch upon the interfacing between the modem firmware running on the modem core and an application running on the application core. Recalling the NRF 9160 communication stack, we are now discussing these layers. Now we are going to discuss modem library and IPC shared memory layers. For the application to interface with the modem core on the NRF 9160 SIP, the NRF Connect SDK contains the modem library. This is a set of standard function calls that can be used in your application to communicate with the modem. The library implements the communication through the remote procedure call RPC library using the inter-processor communication peripheral and a shared region of RAM. The modem library contains, among other things, the socket API, the AT API, and the GNSS API, which interfaces with the respective modules in the modem firmware. So this is a pictorial representation of interfacing with the modem firmware. Let us conclude this video at this point. Let us continue in the upcoming videos. Thank you for watching. Kindly be patient for other videos to appear in this subject. Let us meet in another session of videos. Till then, see you. Tata. Bye bye.